Turn to page 542. We're on lesson 93 today. The first part is on advanced trig identities, and I know that's not you guys' favorite lesson, but we're getting close. We only have till lesson 104, I believe, so we only have 11 lessons left, so there can't be that many trig identities left. This one says, show that 1 plus sine of b divided by cosine of b is equal to cosine of b divided by 1 minus sine of b. All right. So, let's see. This is a completely different new technique. I've got a 1 plus sine b up here. If this were cosine squared of b, then I could change it to 1 minus sine squared of b. And 1 minus sine squared of b would factor into 1 plus sine and 1 minus sine, so one of these would cancel out, wouldn't they? So let's try doing that. Let's multiply by cosine of b over cosine of b, because remember that's going to turn this one into cosine squared of b. Cosine times cosine is cosine squared of b. And then I can rewrite cosine squared as 1 minus sine squared. All right. And then next I can say cosine of b times 1 plus sine of b. And down here, this will factor into 1 plus sine of b and 1 minus sine of b. So what happens to the 1 plus sines of b? They cancel. And then we're left with cosine b over 1 minus sine b. So the last step, which I don't have room for, would be cosine b over 1 minus sine b. And we'd bring down the other side and show that, yes, in fact, they are equal. So that wasn't too bad. Okay, so kind of keep that kind of thing in mind for this next one. Tan b plus 1 over tan b minus 1. We're supposed to show that that's equal to secant b. Gosh, I wrote that way too big. Secant b plus cosecant b over secant b minus cosecant b. All right, so let's think about this. Tangent is sine over cosine, right? Just thinking mentally here. And secant is 1 over cosine. So if we're going to change this into this, we need to get rid of that sine, don't we? Okay, so if we multiplied by 1 over sine and 1 over sine, the sines would cancel, wouldn't they? All right, so let's try that and see. I'm going to rewrite this as sine b over cosine b plus 1 divided by sine b over cosine b minus 1. And I'm going to multiply by 1 over sine b and 1 over sine b. Okay, I'll just put that in parentheses so we can see what happens. So here the sines cancel and we have 1 over cosine of b. Plus here, 1 times 1 over sine is 1 over sine. Down here, the sines cancel again, so we have 1 over cosine of b. And then 1 over sine times a negative 1 is minus 1 over sine of b. And what is 1 over cosine? It's secant. What's 1 over sine? Cosecant. Divided by 1 over cosine is secant, minus 1 over sine is cosecant. We bring that down, and we just proved it, didn't we? Secant b plus cosecant b over secant b minus cosecant b. All right. The next one, I think it's easier than these because it's really a no-brainer. It's just, it gets really long. It says, show that x sine theta plus y cosine theta, quantity squared, plus x cosine theta minus y sine theta, quantity squared, is equal to x squared plus y squared. All right, well, the reason it gets, you have to use FOIL and multiply this out and multiply this out. So I'm going to try to write kind of small so I can fit all this in here. This squared would be x squared sine squared theta, right? Plus, outer will give us xy sine theta cosine theta, and the inner will give us the same, so it's going to be 2xy sine theta cosine theta, plus square this will be y squared cosine squared theta, plus, now we got to square this. This will be x squared cosine squared theta, and that'll be minus 2xy sine theta cosine theta, and then plus y squared sine squared theta. So let's see if anything cancels or if we can add like terms or do anything like that. Okay, it looks like these two are going to cancel. Nothing else is the same. So I have x squared sine squared theta plus y squared cosine squared theta plus x squared cosine squared theta plus y squared sine squared theta. Well, what if we wrote these two together that have the cosine squareds and these two together? We'd have x squared sine squared theta plus y squared sine squared theta, and then plus y squared cosine squared theta plus x squared cosine squared theta. So now we have these two grouped and these two grouped. And out of here, I can factor out a sine squared theta, and what's left is x squared plus y squared. And over here, I can factor out a cosine squared theta, and what's left is y squared plus x squared, which is the same as x squared plus y squared. So now factoring by grouping says we pull the greatest common factor out. So x squared plus y squared is multiplied by sine squared theta plus cosine squared theta. And what is sine squared theta plus cosine squared theta? It's 1. So this is x squared plus y squared equals what we were supposed to show it, x squared plus y squared. So all that work, it's not algebraically difficult, it's just a matter of multiplying everything out and simplifying it. Okay, so enough of trig identities. Let's move on to something else. And this is on page 543. It's down towards the bottom, and it's an easy way to classify whether a triangle is a right triangle, whether it's an acute triangle, or it's an obtuse triangle. Okay? So, first of all, we already know if c squared is equal to a squared plus b squared, that's a right triangle, isn't it? All right? If it's obtuse, start with the c. C squared will be greater than a squared plus b squared. That's obtuse. And if c squared is less than a squared plus b squared, it's acute. Now, how do you know which side to put where? Well, remember, in a right triangle, c is the hypotenuse, right? So it doesn't matter which side you put in for a and b, but c has to be the longest side. So if you look on page 544, the problems are going to be like this. They're super simple. It says, is the triangle whose sides are 3, 4, 5 a right triangle, a acute triangle, or an obtuse triangle? Yeah, I know we already know the answer to this one, but let's just play along and show how to put it in the formula. It's 3, 4, and 5, so 5 is the biggest one. It has to go in for C. So C squared is going to have some relationship to 3 squared plus 4 squared, and that's going to determine whether it's right, acute, or obtuse. So this is 25 has some relationship to 9 plus 16. Well, 25 is equal to 25, isn't it? Therefore, this is a right triangle. All right, so let's try one that we don't know the answer for already. It says, classify the triangle whose sides are 4, 7, and 5. So which one is biggest? 7, so that has to go in for C squared. It's going to have some relationship to 4 squared plus 5 squared. 49 will have some relationship to 16 plus 25. 49, let's see, 6 and 5 is 11, 2 and 2 is 4, so 49 is greater than 41, therefore it's an obtuse triangle. And that's all there is to it.